Can you hear us?
Yes.
All
Can you
right.
hear me?
Yes, yes. So you
Okay.
can start.
So hi, I'm Yeli. Thank you so much for having me. I wanted to say congratulations firstly because this is a great conference, but also because you got to see my face when I woke up in the morning. So today I'm going to be talking about finding unavailable data. So even though I'm a front-end developer, we're going to talk about finding unavailable data in Python because sometimes, like everybody, I have questions that are difficult to answer. So like a couple months ago, one of those questions was, what is the male equivalent of a nun? And so when I looked it up, it turned out a lot of people had similar questions. So across all like the question form sites like Google search results, Quora, Stack Exchange, people were asking these questions. So I thought it would actually be a useful tool to have. So I decided that I would make an API and a tool where one, you could find all the gendered words, and then two, you can find the equivalent of any gendered word. So first of all, what is a gendered word? So there are words like this that apply to a certain gender. Some of them have equivalents like lady and gentleman, and some of them like cougar or Iron Man don't actually have an equivalent in the English language. So the first thing I did, I started, okay, where can I find this data, right? So I looked on Google for days and days until I realized that the data set did not exist and I would have to make one myself. So the first question I had to ask was, where and how do I get this data? And getting data from me, it's usually one of three ways, either APIs, static data, or web scraping. But before I started coding, I had to know what my criteria was. So to start with, to create this list of gendered words, I wanted any word in the dictionary, in the English dictionary, that had one of these terms that you can see on the top in the definition. So for example, businessman would be a gendered word because it has man in the definition. And then also archeress would be a gendered word because it has female in the definition. So I started looking for some APIs, and the first thing I did was go to API Heaven, which is programmableweb.com. It's the largest API directory on the web. So I looked for dictionary APIs, and I found an API called WordNick. So WordNick is the world's biggest online English dictionary by number of words. And WordNick has a free API and a feature called a reverse dictionary. So the reverse dictionary basically means for this word that you're searching, find all the words in the dictionary that have this word in their definition. So I could find all the gendered words by asking the API for a reverse dictionary of woman. So this is the reverse dictionary of woman. And for the reverse dictionary of all of these other terms. So that's what I did. I loaded in the WordNick API in Python, which is the setup is in line 1 to 5. And then I created an array called all words that I would store the words from the dictionary. And then for each of those terms in line 7, I call the WordNick reverse dictionary on those terms. And I say, okay, I want a noun. And then I add all of those words to the all words array. But actually, so I discovered the API didn't have all the information that I wanted. So it said on the website that there are 3,000 words, or about 3,000 words that have woman in their definition. But I only got about 400, so I had to find another data set. So I stored the results I got from WordNick and then went on to find another data set. So this time it was a static data set. So the second way you can get data is from static data sets in one of these other formats. So I looked on GitHub and I found a dictionary in JSON format. So I read that in using Python. Python has a JSON module that you can just import. It comes loaded with Python. So I used the JSON module to open this dictionary of terms. And then for each of those results in the terms, I got the definition for that term. So now we have all these dictionary words. We have all the words from a dictionary. So we need to find the gender terms. So words like lady, gentleman, princess, woman. So how would I get these words from a data set of all the words in the English language? By looking at the definition for one of these terms. So like I said before, if a word has one of these terms in the definition, then it's a gendered word. So how do we check that? So in Python, you can say if string in string. So you can say if woman is in the definition, but then you have this long list of if conditions. So instead of doing this, I decided I would use regular expressions. So a regular expression is a sequence of characters that define a search pattern. For example, my name is Amayeli. but people often misspell it because there are different spellings in other tribal languages. So if I wanted to search for my name, but also for all the misspellings of my name, I could create one regex strict pattern to match all of them. So like this would be the pattern. You match OM, and then you match A to Z, and then you match YE, and then you can match either M or L, and then again you match A to Z, and that can get all the different misspellings and the actual spelling of my name. And then you can also use regular expressions to search in your editor. So if instead of looking for one particular thing at a time, you can use a regular expression and look for multiple things at a time. So coming back to this, what we want is to make a regex pattern for all of these terms so we can search for them in definitions. So in regex, the pipe symbol, so that word that goes like that, represents or. So this is saying match woman or female or girl or da 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 da. So and then if you find any of these in the string in the definition, then do something. But the issue with that it also looks for substrings, so not just whole words. So I need to change the regex up a little bit. So I use something called a word boundary. So now it's looking for whole words and not parts of a word. So the word boundary, the slash and the B, that's saying I want a whole word and not just a part of the word. So you can see now the matches are different. On the right side, it's only matching man and boy and not like man and boy when it's part of another string. But I also want words like grandfather, right? So what can I do? So I use the word character, which as the name implies is for a word. So when I add a word character, then it matches father, it matches grandfather, it matches grand-father. So I'm going to go through the regular expression one by one. This is saying, this is a group. So this is a group all of these together. And then the square brackets are saying this is a character set. So you can match any of the characters inside the set. And then slash W is saying match a word. And then a dash is saying match a dash, and then we end the set, and then it's saying the star is saying you can match 0 or more than 0 of the preceding tokens. So match 0 or 1 of whatever came before, and then we end the group, and then this is saying this is optional. So it doesn't have to be grandfather, it doesn't have to be grand-father. It can also just be father. So this was the final regex string I came up with, which accounts for a lot of things, part of which I explained, but you can ask me more questions about like some other things that are in here. So after I finalized the regular expression, I went through the dictionary, and then for each entry in the dictionary, if the definition contained one of those terms, so in line 7, I'm actually searching the definition for that pattern that I create in line 3 and line 2. And then if you can find one of these terms, for example, in the definition, then you can add it to our list of gendered words. And so from that, I got about 8,000 words, which I thought was pretty good. But when I went through the list of words, there were some words in there that I didn't want. So there was words like lioness, like rabbit test, there was studmare, which I don't know what that means. But like there were a lot of animal words and there were a lot of words that I didn't want. So I decided I would look for patterns in the incorrect words so I could find a way to remove them. So one of the patterns I found was that in some of the incorrect words, the definition included the gender term being used as an object of a preposition. So I mean like this, like waterfall, in the definition, it says of a woman's back hair. So it has the gender term woman in it. It has the term we're looking for, but it's the object of a preposition. So it's not actually a gendered word, just like Peter is a popular name for a man, but it's not actually something you call any man or can call any man. And then mantelet, again, I don't know what that is. So I decided, okay, I'm going to find all the words that use the gender term as an object of a preposition, and then just remove them from the dictionary, remove them from my data set. So how would I find words that fit this category? So first I had to isolate the parts of the string that I wanted to look at. So I trimmed the definition. So in regular expressions, when you search for them in a string, so when we do the search in line 7, it actually gives us the where it finds the word. It gives us the location. So I use that location to trim the string in line 10. And actually, there should be a variable called end index, but it's not there. So just imagine that it is. So when it finds, for example, if the string is the one in line 5, where it finds man, it will store that index. And then we can use that to trim the string. So it stops right where man is in the string. So after we trim it, we can remove any punctuation. So the string object, the string class in Python has a list of all the punctuation. So you can translate the string, which is what we're doing in line 4, to remove all the punctuation. But I mean, so like imagine if the string had punctuation. So if it was a string in line 7, the result would be line 9 because we removed all the punctuation. So after I've trimmed and cleaned the string, the next thing I have to do is find the preposition in the string. So to do that, we can use something called NLTK, which is Natural Language Toolkit. So it's for processing the English language. So the first thing we have to do is tokenize the string. So tokenization is chopping up a string into pieces and then removing stuff like punctuations. So you can see on the right, when we say tokenize, a common baptismal name for a man, then it breaks up the string into different pieces. So after we tokenize it, we can use a POS tagger, which is basically a part of speech tagger. So it tells you what the part of speech of each word in the sentence is. So we can see after we run it through the POS tagger in 8, again, part of speech tagger, it gives us the part of speech of each word in the sentence. So in line 9, you can see common is an adjective, baptismal is an adjective, name is a noun, man is a noun, for is a preposition. And I know this because I just looked it up. I just looked up what the tags mean. So you can see, yeah, JJ means adjective, and N means noun. So now we remove all the A's and the ands and the thes because we don't really care about them. So I didn't really want to clutter out the space with that function, but the filter tags function removes the A's and the ands and the thes. So now we check the word before the gender term. So the gender term is man, right? That's the last term in the array because we trimmed the string right where we found man. And then we check what the term before man is. So that's in line 7, we store what the term before man is. And in line 5, that's something called, it's an array of tuples. So a tuple is a data structure in Python. So you can access a tuple the way you access an array using like the square brackets. So we get, in line 7, we get the part of speech of the word before man. So in that case, that's 4. And then if that part of speech is IN, which is a preposition, then we return false. So we say, okay, we don't want this word in our list. And then the next pattern I found is that there were a lot of clothing items. So there were words like hobble skirts, pajama, but like pajama, you can't call anybody pajama because it's not a word for a human being, yet alone a gendered word. So I said, okay, I'll remove all the words that have any kind of clothing item in their definition. So to do that, I found a list of clothing items online. So I can remove any word, any definition that has one of these clothing items in the definition. But when I looked up the API for that Collins dictionary, it said I have to apply for a key, which I did, and I'm still waiting. I applied maybe 8 weeks ago. And then also it says I have to pay if I make more than a certain number of API calls, which I didn't want to do because I'm not working. So unavailable doesn't only mean that it's literally not there. It could also mean that you can't pay for it or that the steps to get it are very, very long. So I said, okay, I don't care about your API. I'm going to scrape your website. So instead of using their API, I decided I would scrape their website. So web scraping is a tool for extracting information from websites without using their API. So it involved just grabbing the HTML dynamics of the website. So for web scraping, we're going to be using 2 libraries in Python, url_lib.request, which all it does is open URLs, and then Beautiful Soup is for parsing HTML documents. So the first thing you have to do is figure out how the data you want is, the first thing you have to do before you want to scrape a website is figure out how the data you want is structured or represented. So the data I want is in a link that's the child of a span element with the class TD. So yeah, you can see that. And then, so in Python, I open the URL. The URL is on line 2. I use url_request to open the URL in line 3. I load that page into Beautiful Soup, which parses the HTML in line 4. And then in line 5, then I'm like, okay, this is what I want, get it from me, which is similar to working with JavaScript and manipulating the document object model. And then in line 6, I say get text. So get text with Beautiful Soup is kind of like inner.html or text content in when you're working with JavaScript. It works. So I get this list back from the website, and then I use this list to filter the array of gender terms. So I remove all the definitions that have any clothing item in it. And then it came down to about 4,000 words, which was much better. There are a lot of words that I didn't want, so I got to remove them. And this is a sneak peek at the website as it currently is. So you have all the gendered words, and then you can filter them by their gender. You can search for a word, and then the last thing I wanted to do is to actually find the equivalent word. So lady is to gentleman, prince is to princess, actor is to actress. So to do that, I can use something called word2vec. So you can see in this example that you can get what the equivalent term for a word is. So woman is to queen, as man is to king. And word2vec is an algorithm that transforms words into vectors. You feed the algorithm a ton of text, and then it groups words together in space if they are used in the same context. So it's a math thing, but all you need to understand is that it groups words in space, in like actual space, like X and Y axis, etc. So the algorithm is based on the idea that a word is characterized by the company it keeps. So a word is close to another word in space. A word is close to another word in space if they appear in the same context. For example, if we give the algorithm this text, if we give word2vec this text, it will position Maggi and salt and seasoning close to each other because they appear within the same context. So the model it creates will indicate that salt is closer to seasoning than salt is closer to chair, because salt and chair are not used in the same context. Maggi and salt and seasoning are stuff you can interchange in a sentence. So they have the same context mostly. And then with that model, you can do stuff like getting the similarity of words. So we see here, we're getting the similarity of woman and rectangle at the top, which is a very low number. And then the similarity of woman and wife at the bottom, which is a high number, or a high-ish number, 0.8, as compared to 0.08 at the top. And then you can also, like I said, do word analogy. So woman is to queen, as man is to king. To work with the word2vec algorithm in Python, you use a library called gensim, or that's one of the libraries that you can use, or the one I used. So Google has trained a model using the word2vec algorithm on like 300 million words. You could train your own model, but I don't have access to 300 million words, and I think other people don't. So probably, depending on your project, the best bet might be to use the Google word2vec model, because it's been trained on a lot of words. So it's most likely going to have all the words that you want. Maybe not all, but more than any other model, I think. So we loaded the Google word2vec model, which has all the vectors for about 3 million words. So we loaded in lines 1 to 3. Number 2, line 2 is just the file path name, and then we actually load in the model in line 3. Line 1 is importing the gensim library. And then we say, okay, so the example we're going to use is woman is to wife, as man is to what. And then, so that's what we're doing in line 9. We'll say woman is to wife, as man is to what. And then the result, if we get it back, we store the result and the score of the result. So the score would be the distance in space from one word to another. And then if the score is above a certain number, then we can return and say, okay, yeah, this is the equivalent. So I'm going to share the project if I can. I think I still have time. Okay, yeah. So this is all the list of all the gendered words. And then for a particular word, let's say ant, you can. Oh, wait, can you see the screen? Yeah, so for a particular word like aunt, you can find the equivalent. So it has all the list of words, and then you can get the equivalent for any of the words that have equivalents. And that's it.
Thank you, Yeli. So, any questions?
Thanks for your presentation, Yeli, right?
Yes.
I have a question though. The example that you used to explain this particular procedure you took us through is using words. But some days ago I was talking to a friend of mine, and the person asked the question that how do we get financial data off Twitter? And I was like, okay, get financial data off Twitter. Obviously, you know that all kinds of things get on Twitter, right? But I'm thinking, do you think that the person actually framed that question properly, or how would you go about something like that? Like,
well, I mean, I think you have to start by being more specific. So what kind of financial data do you want?
General financial data, basically. They were not very, very specific, because when we started the conversation, it seemed as if I wasn't understanding what the person was saying, but it kind of, your presentation kind of resonated, because it felt like, obviously, there is some kind of like data that you get, obviously there's some kind of data you get off Twitter that's probably financially related, because they use all sorts of different, like, how do I call it, criteria. There are all sorts of things, as I said, all sorts of things get on Twitter. You could get words, right? You can determine sentiments of people pertaining to a particular topic, right? So my question basically now is, how would you go about something like that? As I said, you don't necessarily have to go through Twitter, for example. How would you go about financial data for a particular, maybe like place, maybe like Nigeria or Lagos? You're trying to find out, how would I call it, earning capacity of people in Lagos. How would you go about something like that?
Okay, so I'm going to give like a couple examples. There was, I think at some point here, there was a talk pay hashtag where people wanted to share like how much they were earning. So they used the hashtag talk pay. So in that case, it's be easy. You just get whatever, you just get all the tweets using that hashtag, and then you can put that in a Google, in like an Excel sheet, which is what they did in that particular example. If people weren't using a hashtag, so you didn't know anything about the tweets unless except that they were using numbers. So you could use something like regular expressions. So you know how like or if you're like trying to pay for something on a website, they have a field for your credit card number. Mm-hmm. And like they know what's like a credit card number looks like, right? Yeah. So if you wanted to get something like credit cards, you could create a regular expression to say, okay, this should be, in this group you have like 3 numbers, and then in this group you have like 5 numbers, and so like that will get back all the tweets that have a specific format like that. So you could do that, but like again, I'm not sure what specific financial data. So like if you wanted to get something with everything with like the Naira sign or N and then a number in front of it, that could also be a regular expression. So you could do like in the regular expression, you could do match an N and then match a series of numbers that are in a specific format. So you could use regular expressions that way, or you could like look for specific terms in the tweets. So like my salary or just salary or money, or you could look for specific items, and that's the first thing you would have to do. The first thing I would do is see what the Twitter API affords me, and then see if I can get all the information that I need through the Twitter API. And then if I can't, then I'm like, okay, how can I scrape the Twitter API using whatever regular expression string that I create?
Okay. Thank you.
Any other question?
Good morning.
Good morning.
Yeah. I want to ask, how do you scrape data from authorized sites or sites that require you for authentication or authorization before you can actually get access to that page? How does it go about?
So you can use something like, I'm trying to remember what it's called. But I can post it in the chat after. There's something, I think, there's something that, okay, it's called Puppeteer. So Puppeteer, you can pretend to be like somebody using a browser. So Puppeteer, you can go to a page, you can sign in all from like your computer through programming. So you pretend to be like a person using a browser using Puppeteer. So when you go to the website, then you fill in all the information you wanted to fill. Obviously, you would have to have your password and your login information. Give that to Puppeteer, and then Puppeteer would put that information into the browser. And then from there, you have access to the page with the data that you want from what that the page is authenticated.
All right. Thank you very much.
So we have just one more question for you, Yeli.
Okay, cool.
Hi.
Hi.
When dealing with non-pretty links, how do you tend to do web scraping?
Non-pretty links.
Yeah.
Can you give an example?
For example, URL with non-English words, like combination of numbers and stuff like that.
I mean, you can just replace, like, the URL I showed for the Collins dictionary, you can just put that in. If there's any issue with like the type of string, so if there's a character that's not a word, then Python, this is how you do it in Python, but I'm sure you can, like other languages have the same functionality. You can do encoding or decoding. So like, yeah, so you can use encoding or decoding. So you can encode the string before you give it to URL request, which opens the string, or you can decode it first. So you can have a function that decodes the string first, or encodes the string first, and then give the string to the thing to open.
Okay.
But look for like encode or decode in whatever language you're using.
Thank you very much, Yeli. Thank you for your presentation. Sorry for waking you up early.